Hi and welcome to part 2 of this adventure on the assembly of the Lateral MOSFET High Fidelity Power Amplifier by Elliott Sound Products. Hope you enjoy. Greetings, the Astro 30 here yet again on this MOSFET power amplifier, which uses lateral MOSFETs, as explained in part 1 as to what they are. There'll probably be a card up here if you haven't already seen that video. Anyway, if you're here, you're in for a treat because we're now going to finish the assembly on the power amplifier module and we're going to test it. And I'm going to go through all the procedures of how I'm going to test it and how you should probably test it so you end up not destroying it for a start and destroying expensive loudspeakers. So let's get on with it. So now I can move on to capacitors. I'm going to start with the ceramics first, and MKTs and stuff like that, and yeah, we'll come back. That's all the smaller capacitors, smaller profile capacitors that is. That large ceramic capacitor, which is supposed to be 500 volt, that barely fits in there. There's next thing to do would be to stick the variable potentiometer in there, or else it's not going to be adjustable for its bias. And because MOSFETs don't like having a lot of current going up their gates, it would be a good idea to make sure that this is at its minimum rotation first, and then measure it to make sure. Right, I heard it go click. I really should. However, I'm not going to unpack my multimeter for that. I'm just going to put it the correct way around as it's marked on the board here. Oh, I'm missing a link wire too. So I'll put the link wire in once I've got access to it. Getting that link wire in there was harder than necessary. But I got it in there. And yeah, perfect. As I say, I'll measure that resistance because there's the join there. So I measured that resistance of this pot with a multimeter before I power it up. It needs to be at minimum, so you're putting the minimum amount of current through the MOSFETs, or you can destroy them with too much voltage. Well, not too much voltage, too much current flow. I think I need a break, but the next thing to mount would be the electrolytic capacitors, because the only thing left now is the MOSFETs themselves. Okay, I went and had a break. The electrolytics are now in. I have forgotten to put the MJE350 in, which is our VAS transistor. Without it, it's not going to amplify. And that's Q7. Now, which is right there, but it's not marked. Well, there's a thicker line there, so I believe the flat faces towards the input stage section, all these small signal transistors, and it doesn't require a heatsink, so it can go as far down as you want to put it, I suppose, and solder him in. There's an extra hole. Oh yeah, that's for the capacitor. I was wondering what the extra hole was for. Don't mind me, I'm here all week. Go away please, phone. Did that should take? Yeah, it looks like it. Now it's starting to look like an amplifier. So the only components left now is a couple of ceramic capacitors and the MOSFETs. So I'm going to install the MOSFETs now, and they need to mount on the underside of the board coming up through the component side. So if I can get that out of the bag, that'd be nice. Bloody thing. F you. Right, so now these will need to be lined up with the hole and bent appropriately. So I'm just going to eyeball it right now that that's the center. Yeah. So I need to bend it around about 6 mil up the leg of the transistors. We're a bit out of focus, are we? Or is that me? So they need to be bent at right angles so that they poke up through to the component side. Make sure that you put the correct transistor in the correct place. I'm hoping, well, it doesn't matter, it'll be the same on the other side anyway, but which one's this? That is the 10M20, which is Q8, excuse me, it's Q8 and Q10, which is on this side of the board, so I had that wrong, but that's alright, that should still fit. It does just need to bend it up a bit. Now, the thing with this is, to make sure that these transistors stay flat to the board, what I would suggest is putting a screw through from one side and a nut on this side just to hold it flat so it's perfectly flat to the board. Right, so I'll just bend up the rest of the transistors, put them in and attach them with some screws. Okay, and that's what I meant, because that's how it's going to mount to the heatsink, and that keeps the transistors nice and straight and central with the holes. Now we can solder them. One word of advice, do not cut the ends of the leads off yet. Because there's a reason for that, because those ceramic capacitors have to go across the P channel MOSFETs, across two of the component legs, otherwise the amplifier will oscillate. And just another point, do not substitute these MOSFETs out for switching types, they will self-destruct, as it is mentioned in the project article. They must be lateral MOSFETs. Just be careful of this pin here because it's connected to that hookup wire. I don't want it melting through it. It should still be okay. I mean, if anything, before powering it up, it would be a good idea to just measure across the supply rails and ground to make sure it's not shorted, because that wire is a ground. As long as it's not shorted, then that wire is perfectly fine. Just try and avoid as much heat on this particular pin as much as possible, just enough to solder the transistor leg in. So those transistors are now soldered in. Looks like my wire survived. So next thing is to actually install the ceramic capacitors across the legs of the MOSFETs on the P channel, and they go across the gate and the sources. So that one's going to be a bugger to get to, but the way I'm going to do this is, if I so can, is try and wrap the leg of the capacitor around the leg of the MOSFET. Sort of like that. It was a bit more wider than I wanted it to be, but okay. And then we just solder it in. That's the reason why we do not cut the legs of the MOSFETs off yet, because then you'll never get the capacitor on there. Get that one out of the way. There we go. It doesn't have to be super tight as long as it's on there. Okay, that's soldered. Then we can trim the end of the capacitor lead off to make it neater. did absolutely nothing. There we go. And then just gently bend it up. Don't want too much stress because we don't want it shorting on the resistor, even though that leg goes to the same point. Ugly as that looks, that is the intention. Now I've got to do it a second time, but I might actually lay it the opposite way. And I just so happened to get the text facing the correct way on the board. Yay me. Found it easier to put a little bit of a curl on the leg first before trying to install it. Makes it for an easier time. I know you can't see what I'm doing, but I can't see what I'm doing either. And that's a bad thing. Okay, get that to twist around like that, that'd be great. Make sure it's all the way down, yes. Then I can solder it. Beautiful. And just carefully bend that up. There we go. So that is the complete assembly completed. Well, you could cut these excess leads off. Is it really worth it? No, probably not. I'm going to leave them on there, it's fine. So that is the ESP. Man, that's got a bow on it. Look at it. That's the ESP Project 101 Revision C board soldered and completed. I did end up with a resistor over, but that's only because I miscounted the number I actually needed. I only needed one, not two, so that's fine. Yep, so now it's up to testing it, but I'll have to wait until after I've moved to do that. First thing will be first is to check across the supply and ground to make sure that it's not shorted, and to make sure that it is set to minimum resistance, so we're at minimum voltage. And I'm assuming, as you look at it that way, it's fully counterclockwise if you install the pot the way it's supposed to be on the footprint. But yeah, I'm quite pleased with how that turned out. It took me about 2 hours to assemble, but that was only because I was filming in between. Yes, the fuses are in. Alright, so I suppose we move on to the testing phase. I'm not going to upload this as it is without the testing phase in it, so that's going to be the next thing. Alright, at least there's more room for a tripod. Anyhow, we're about to test this. First things first, make sure that trim pot is set to minimum resistance. Handily, we can connect our multimeter probes between this end of this resistor and the end of that resistor, because there's tracks running back to each end of that trim pot. One there. And one. If I can get it to stay on there. There we go. Yeah, close enough. So if this was assembled right, it should be fully counterclockwise is 0. Yeah, that's as far as it goes. And if I turn clockwise, as we can see, it increases. Okay, set that back to minimum. Next is to do a power on test. I'm using plus minus 20 volts for this test, which is perfectly fine. It's going through two 100 ohm safety resistors, and I've got a multimeter connected across one of them to measure the DC volts, which should not be any more than 2 volt. If it is, there's a problem. At 2 volt into 100 ohm, that is a current draw of roughly 20 mA. So now I'm just going to plug the thing in. Hopefully nothing goes bang. Oh, look at that. The multimeter probe's around the wrong way, but we've got 314 millivolt, which is probably about 3 or 4 mA. Right, with the preliminary test completed, I've now bypassed the resistors and connected the supply directly. And now I'm going to check what DC offset on the output is. And that's measured between output and ground. And I would suggest doing these tests in this order the way I'm doing it. Power up. Very good. There's very little DC on the output. It's negligible. Brilliant. It's passed the second test. I'll leave the bias set up to Rod Elliott's secure pages. So you're going to have to purchase a board to get that information. I'm not going to tell you how to do the bias adjustment. So the next step is to see if it works as an amplifier. Got the function generator hooked up, well, oscillator, the oscilloscope, dummy load, jerry rigged into the board, and the power supply. So you can focus on the oscilloscope screen whilst I plug it in. Boom. Nice stable 1 kilohertz signal at around 11.2 volt peak to peak. Nice. Now you'll notice I'm running this without a heatsink. You can for testing purposes, but not for too long. So drop that right down. I want to see what its maximum output is at this voltage. Oh, clipping there. Ooh, badly. 32 volt. That from memory is around about 20 watts. Actually, I stand corrected, it's actually 32 watts. That's peak continuous, so it's not RMS. So half that, so it's 32 volt peak to peak, so it's 16. So we take the RMS value of that, which is 11.3, times that by itself. 2 equals that, divided by our load. Yeah, about 15, 16 watts in the RMS value. Not bad. Alright, so I suppose it's time for the all-important sound test. I've got everything hooked up and the speaker connected. Jesus. Let me try that again without the input connected. Okay. Take 2, I removed the signal ground from the speaker ground. Sounds alright. Speaker doesn't. That could be the laptop too. Alright. Change to my phone. Well, it works, but how well it works is subjective. I don't think a laptop or a phone is a good device for an audio source to test amplifiers with. Well, not at least the ones I've got anyway. Plus that speaker sounds absolute nasty crap. Anyway, that's the ESP Project 101 150 watt power amplifier module. Built, tested, it works. It'll probably work better in the application I'm going to be using it for. So I'm going to leave this video here. If you enjoyed it, please remember to rate, comment and subscribe below. And you can always follow me on Facebook and become a Patreon member for as little as $1 a month. I'd like some more Patreons, please. Anyway, thanks again to Jeff for sending me this. Anyway, this is Ash right there saying, see ya, have a great day.